there, everybody. I hope you are doing well tonight. We, of course, are here for another Creation Science Theater, and we will be starting the show very soon. Just going to let people start to filter on in here. Hey, nice to see we actually do have people here. Hello, Rosnia. Hope you're doing well. It's been a little bit since I've seen you, I think. No, you were here for the last show. I remember because I tried to do a Zoidberg impression, and it did not go super well. Let's see. I am curious about something. If anyone in the chat is familiar with 3D printed things, any advice for making this? Whoop. Sorry. Any advice for making this a little wider? So this is a 3D printed T-Rex skull that a friend gave me back in college. But somewhere throughout the years, the jaw's just gotten kind of squished, so it no longer articulates properly. It's got a big offset. If anyone has any advice for, stretching it out so it fits again, that'd be nice, because I love this skull. Even if it's a little rough, I never sanded it down like I was supposed to. But I don't know. It can't sit upright because the jaw doesn't fit. So it's just over here. What can you do? Oh boy. Why not Zoidberg? That was nowhere near a Zoidberg. I'm sorry. That was bad. Why not Zoidberg impression? I can't do it. I can't do a Zoidberg, sadly. But anyway, we're not here for impressions, though I'm sure there will be a few of those. Today we're here to continue our presentation by Ryan Cox, a guest over at the Standing for Truth channel. If it has been a couple weeks, so I'll just do a quick overview. So this is Ryan. Say hello to Ryan, everybody. Ryan is a young Earth creationist, I guess I'll say propagandist. He tours the US with a whole collection of dinosaur models and tells people that the Earth is young and dinosaurs are proof of that, basically. Every once in a while, he does these presentations online. He's done a couple now for Standing for Truth. I believe this is his second, though he might have done more. But I've also seen him on other YouTube channels. Gonna be honest, I don't know much about the man personally. He seems personable enough, at least on the streams, but no idea what the guy's like. But he says a lot of very wrong things about dinosaur anatomy. On the last couple streams, we have been working through his presentation here. As you can see, we are 34 minutes in. Well, yeah, just about 35 minutes in, actually. So averaging about 17 minutes per stream. Wonder how much we'll get through today. I will say, when it comes to this stream, it is going to be an open lobby, an open theater. So if anyone feels like hopping on, you're welcome to. Just give me a quick wave on camera when you pop in so I know you're not too weird. It's happened before. Just a quick wave on camera, then you can shut it off and join the stream. It's okay. You do not have to show your face to the public, as it were. But you are welcome. If no one joins, that's okay. We also have a super chat goal. We're going to try to hit 10 super chats. And if we do that, then we're going to take a look at some dinos from Jurassic World Evolution, because there are some really cool ones. There's a lot of really bad ones, but there are some cool ones too. I'm going to say hello, DM Wing. Hello, The Fearmonger. And hello, Robin Webster. Hello, hello. Well, without any further ado, we have hit the 5-minute mark, and I think we shall get started. All right, Ryan. Oh, right. I'll rewind a little bit. But when last we were here, Ryan was giving us a definition of reptile from a kid's book. I'm not kidding. It's actually the thumbnail for this stream. I'm going to go back. Maybe not that far. Yep. So he's going to pull out his book, and we're going to get a little definition of dinosaur from a children's book from like the 80s. The best source of true information.
And their anatomy. And this is a fun little book. This was given to me by my great uncle. It's from the Oblong Grade School of Oblong, Illinois, the only oblong in the United States. It is a book about reptiles from 1957. Oh, this is modern science, right? Well, I'll tell you, it's a little better than some of the modern science. I'll tell you that. It talks about animals, how they need food and air, and how they need to grow. And reptiles are animals that need food and air to grow. And all reptiles have backbones. They breathe with lungs. And they have scales on their bodies. That's right. We know reptiles have all those features. Many animals may have backbones or lungs or scales, but they're not reptiles. Reptiles have backbones and lungs and scales. All reptiles, how many? All reptiles are cold-blooded animals.
That might be, I think that's the exact shot I have in the thumbnail. So yes, most modern reptiles are cold-blooded. And when you're making a book for children, sometimes you don't want the added bit of nuance there. Let's talk about warm versus cold-bloodedness for a second. So being warm-blooded and cold-blooded are just two sides of a spectrum when it comes to metabolism. That's all it is. Metabolism is the rate at which you process food and perform other bodily functions. If you're warm-blooded, you maintain a high body temperature so you can perform more functions faster. Birds and mammals are both warm-blooded, just as a general rule, but they do it in different ways. I don't remember the exact differences off the top of my head, but mammals do a lot of extra processes in their cells to generate heat. I believe mostly in the mitochondria, but I could be wrong. And we also like twitch. We shiver. That's why you shiver when you get cold. It warms you up. However, note how I said earlier that warm and cold-bloodedness are on a spectrum. That's because there's a whole range of animals that are more cold-blooded and that are more warm-blooded. And everything in between. And there are extremes to both ends, too. For example, just within reptiles, your average lizard is, yes, cold-blooded. It's mostly dependent on its environment for its body temperature. But there are reptiles like monitor lizards and crocodilians that have a slightly elevated metabolism. They are more warm-blooded than other reptiles. They're higher up on the spectrum. If you want to say cold is down, hot is up. There's variation within reptilia, just in general. Even if you don't include birds, for whatever reason. Because here's the thing, and we're going to go over this again later, I'm sure. Birds are reptiles in the colloquial sense. Reptiles are sauropsids, which is a large group of vertebrates. It includes crocodilians, birds, and lizards. And birds and crocodiles are more closely related to each other than either is to your average lizard, because that's how family trees work. Anyway, kids' book has to simplify, but Doc likes to talk, so Doc does not oversimplify. And yes, Rosnia, you are correct. It seems like for many early crocodiliforms, they were warm-blooded. Like hot-blooded would be a better way to put it. Archosaurs in general seem to have had an elevated metabolism. And archosaurs are the group that includes crocodilians, birds, dinosaurs, and pterosaurs, and a whole host of other things. Almost all of them seem to have been hot-blooded or warm-blooded, have a high metabolism. With very few exceptions, and those exceptions appear to have evolved a lower body temperature from a higher body temperature ancestor.
They are no warmer than the air around them. So if it's 70 degrees outside, the reptile's 70 degrees because their thermal regulation does not allow for them to generate their own heat. If it's 110 degrees outside, they got to find some shade, some water to cool themselves down. If it's only 40 degrees, 50 degrees.
I mean, if it's 110 degrees, you should also find shade and water to cool yourself down. Warm-blooded animals maintain they do their best to maintain an internal body temperature that's around a certain range. Going outside of that range is bad because they are optimized for that specific range. Like hypothermia is a serious problem for humans, for example. You don't want to get too cold, you don't want to get too hot, but that's just by a couple degrees, and your evolved cooling mechanisms can only do so much. Especially with like the heat wave going on right now in most of the US, drink plenty of water and stay cool, please.
Well, yeah, it's a little too cold. They're cold-blooded. Dinosaurs are reptiles. They're cold-blooded.
No. Just because you want to oversimplify things does not mean that dinosaurs are dinosaurs are cold-blooded because they are reptiles. As I said, archosaurs in general seem to have been warm-blooded ancestrally. Also, we have a guest.
Hi.
Hello, Dom. How's it going?
Hi, you can hear dogs in the background.
Oh, that's terrifying.
Yeah.
How are you doing tonight, man?
Good. I'm only here for a tiny bit as I've been recruited by friends, but I'll be here for the little bit that I can.
All right. Right. Well, we were just talking about how certain animals are warm-blooded and cold-blooded, and since dinosaurs are reptiles, they must be cold-blooded.
That's not even how warm-blooded and cold-blooded works anymore. Like,
Yeah,
sharks are warm-blooded, kind of.
Yeah, great whites. Well, they
and
maintain
salmon,
a higher
right?
body temperature than the surrounding water, but yeah.
Yeah, great whites and salmon.
Great whites, salmon, and at least some kinds of tuna. I know tuna do it too.
Yes, and also you can technically argue that Antarctic fish that have warm-blooded and cold-blooded basically means nothing. Oh, why is it? I think the sun.
It's getting light from your window.
Yeah, I think the sun attacked me. Anyways,
Yeah.
God, that makes me look awful. That's fun.
It's fine. You can be a vampire.
Yeah. You guys done over there? Okay. But yeah, warm-blooded and cold doesn't work like that anymore. One, just because there are reptiles that are warm-blooded, kind of, right?
Yep. Monitor lizards and crocodilians both maintain an elevated body temperature.
Yeah. I thought some snakes do as well.
I wouldn't be surprised, just considering how varied snakes are.
I thought sea snakes did.
I would have to look that up, but I wouldn't be surprised.
Yeah. But no, yeah. That's not how... Again, the old-fashioned idea that reptile cold-blooded, mammal warm-blooded doesn't work because it's a scale. It's a scale. The lowest scale is amphibians. The highest scale is most living mammals. But
I would argue the highest in the scale is birds. Birds usually have really high body temperatures. But you missed it, but he was using an actual children's book from like the 60s for his definition of reptile.
Oh no, I saw that. Don't you worry. Don't you worry.
Well, I think he's about to talk more about the raptors in Jurassic Park because he doesn't like that they're shown as warm-blooded.
That's great for him, I guess.
I mean, that's most of this guy's deal. He doesn't like science when it disagrees with him because he thinks dinosaurs have to be cold-blooded and slow.
But why?
Because creationists are always stuck in like the 60s.
Like, but
Like
see,
this guy despises the dinosaur revolution.
my issue. Okay, so we're gonna be on a tangent. Creationism, sure, whatever, believe what your own. But a lot of creationists, sorry, some of them do use the most accurate scientific evidence. At least a lot of the time, and then they go backwards from that to explain why they're right. But this is
Well,
the
they
first time
they
I heard.
usually butcher it really
Yeah, they
heavy.
usually butcher it, but they're still using the quote unquote accurate stuff. I've never heard a creationist not use the most accurate representation to butcher. No, the 60s was right, famously.
Yeah. Oh, and I see there's some confusion in the chat. So the dinosaur revolution
Oh, yes.
was a period in the 60s through the 80s when we completely updated our understanding of dinosaurs. There were a lot of discoveries made that helped link dinosaurs to birds.
Deinonychus.
And yeah, Deinonychus was instrumental in it. Just the movie raptors in Jurassic Park, Deinonychus, this dinosaur.
yes.
But yeah, a lot of stuff got updated at that point, so we call it the dinosaur revolution.
Most paleo art that you see that's like, if you ever had an early dinosaur book from the early 2000s, a lot of the paleo art in there is paleo art referencing the dinosaur evolution. You get a lot of like big carnivores running around, a lot of hunting scenes, stuff like that. It's basically a realizing of, oh, these aren't giant lizards. These are hypermobile predators and herbivores that are, well, predators at the time we thought, oh, is the predators that are like that. We didn't really know that the herbivores were very fast until a bit later because biases.
Yeah.
But yeah,
I mean, exemplified by this illustration of Deinonychus by Bacher.
there it is.
Like, you look at this today and it's outdated and wrinkly and weird, but for its time, you never saw dinosaurs depicted like this.
No, running? No,
running upright.
no, never.
Like, this is the era his children's book is from, and that's his actual source on what a reptile is.
Why? I'm just like they butcher. Like, I'm confused why it's a children's book. At least butcher a scientific book. But it's, he knows the children's book, right?
Yeah, he does. His uncle sent it to him.
And his source for why it's accurate is,
well, because it's convenient for him, and because he's weird and sticks.
Does he have a made-up version? A made-up reason why it's real? Why the children's? Okay, sure.
Well, because we used to know how things were, but then, the people started changing the things and the social commentary and blah blah blah.
He's not even old enough to know that.
It's part of the creationist grift. They always tie it into social issues. Like, if they can change your mind on he said this earlier in the presentation. If they can make you think this about dinosaurs, they can make you think something about anything. Ooh.
Yeah, okay.
Also, yes, DM Wing is Dinosaur Revolution is synonymous with Dinosaur Renaissance.
Yes, it is.
Just different.
It goes by either or. It goes by either or. Technically, there's another one of these in the 90s, but we don't need to get into that.
Yeah, there's been a couple.
Yeah. Anyways, continue this.
That walk upright on their legs. So if they're cold-blooded, can he come up and steam up the glass? No, he can't. Well, it's just a fun movie effect. Yeah, until you pay attention. Listen, the very first.
Did you say you can't steam up the glass?
Well, yeah, because the raptors should be cold-blooded, and if they're cold-blooded, they shouldn't be able to steam up the glass.
That's just breath. That's not even how cold-blooded works. A frog could technically steam up the glass if there's condensation. Actually, frogs don't breathe, but
yeah. Well, I mean, I think he mentions this later, but like if a cold-blooded animal was just outside and it came in, its body would still be letting out hot air. But he complains about that because they say multiple times in the movie that the dinosaurs are warm-blooded.
Okay.
And at least one of them in particular, we have direct fossil evidence of it being hot-blooded. So we'll get to that in a minute.
Yeah, continue.
Also, dinosaurs are part of the trans revolution. Different revolutions, but support trans rights.
Scene when Dr. Grant walks up to the Brachiosaurus. So the first full, incredible moment in cinematic history. Walk up to that Brachiosaurus for the first time, and he's like, "It's a dinosaur." You know, he's so excited. He starts talking about the anatomy. He's like, "Oh, this is totally wrong. This is a warm-bodied creature." And Ellie says, "This thing didn't live in a swamp. Warm-bodied creature." All the dinosaurs in Jurassic Park are said to be warm-blooded.
Yes. Because they are. And we have direct fossil evidence for Brachiosaurus being warm-blooded.
There's also a very easy cheat sheet of if thing is warm-blooded or not. Very easy. And you can do this with anything. If a thing can move around for most of the day without standing still for an hour of it, it's warm-blooded. Even some lizards, monitors are a great example. Monitor lizards chase down their prey. They can swim. It's such a weird. This is such a weird creationism argument. Like,
sorry, I'm having trouble finding the paper now. But there was a study that found the body temperature of Brachiosaurus bronchi. Wait, was it bronchi?
he chooses a scientific paper, which he would just say it's big paleo.
Here, wait. Oh.
Yeah, there it is, right
okay, there. Okay, so Giraffatitan, actually, not Brachiosaurus, but that's the animal in the movie.
Well, also, the other side of the page is the one you want with the temperature.
Yep. 38.2 degrees Celsius.
Yeah.
That's 100 degrees Fahrenheit.
Yeah, that's very
body
hot.
Temperature. And 34 degrees Celsius for Camarasaurus.
Actually, another thing about warm-blooded and cold-blooded. So this is a weird thing, and I don't even know. There's probably a paper on this, but have you ever noticed that cold-blooded creatures, like the cold-blooded creatures we're talking about, ever noticed the things that like outliers like sharks and crocodiles? You know, I've noticed how they're big. Yeah, so there's probably a paper on this, but it seems to get big and be a vertebrate, you have to at least slightly be warm-blooded.
Well, I mean, you need a higher metabolism to just
correct, which internally makes you warm-blooded because that's how that works. But I think what are whale sharks considered?
I don't know, but like the bigger you are, the more energy it takes to move around, and it just gets to a point where you can't just take it all from the sun.
So, by the way, while whale sharks are cold-blooded, they have warm-blooded adaptations. Because they're so big, they inherently act warm-blooded. Less so than like great whites who do the full circulation thing. But no, whale sharks, they are quote-unquote cold-blooded, but they have things built into their system to enable them to stay warm when they deep dive and stuff.
Huh. I didn't know that. That's actually really cool.
Big things need to have a way to maintain body heat for their metabolism. And whale sharks are filter feeders. They don't even need to digest anything, really.
Oh, yeah, comparatively. Like they're not breaking down plants in their guts, which that takes so much energy.
Yeah, that's also the thing. Most plant eaters most big plant eaters need to be warm-blooded.
Yeah.
But the biggest cold-blooded one are turtles. I think it's Galapagos porpoises. Yeah.
I mean, I don't know any body temperature studies on like big synapsids from the Permian or something.
But those are probably
thing I can think of that might be cold-blooded.
Synapsids are probably warm-blooded, though.
Yeah.
So.
Anyway, yeah, you need warm blood to move.
Exactly. especially if you big.
Especially if big.
They're warm-bodied. Why? Because this is an essential feature to become a bird. Birds are warm-blooded. Reptiles are cold-blooded. And we'll get into this later. But in order to have feathers, you have to be warm-blooded. I've talked to evolution.
You don't have to be warm-blooded to have feathers, I don't think.
Okay, because I'm actually going to bring this point. Technically, no. However, feathers and hair help with being more. If you're cold-blooded, you are not going to develop hair or feathers. If you're cold-blooded, you are. It is. If warm-blooded, you are. It is less of a warm-blooded.
Well, I would say you're less likely to develop insulation adaptations.
Well, that's the thing. They're insulation adaptations, and you only develop insulation if you need to keep your body warm.
Yeah, but okay, I will say cold-blooded animals would be less likely to evolve them, but they could hypothetically evolve them.
Yes, they could hypothetically evolve them, but they're not.
Like, there's nothing stopping a cold-blooded animal
They're not
from
going to unless a thing in their environment requires them to, for some reason, stay warm, which in turn would end up making them warm-blooded. Hell, that's probably why it's probably a good reason why dinosaurs are warm-blooded. Because if you didn't know, dinosaurs probably had feathers before they were dinosaurs. Probably one of the reasons why they became. I hate saying it like this because it's not a warm-blooded, cold-blooded discussion. It's a fucking table, like graph. But
it's a spectrum.
It's a spectrum, but that's probably why they landed on the quote-unquote warm-blooded side of the spectrum, because they had insulation, and having insulation enables you to be warm-blooded better.
I mean, at least with archosaurs broadly, like feathers or high body temperature, I think it's a chicken and egg situation, except it actually has something on. Like, you could evolve one before the other, but they
will become the same thing most of the time.
And okay, so there isn't anything cold-blooded that has feathers, at least not that we know of. But the only things that have feathers today are birds.
Yeah, that's the issue with that. So the issue with this is that everything with feathers or fur is warm-blooded. But not everything with scales is cold-blooded, because one, there are mammals with scales that live today, armadillos, because they remade them.
Wait a sec. Aren't crocodile scales modified feathers?
Crocodile scales are scutes. They're not proper scales.
Yeah, but aren't they modified feathers?
Their scutes aren't. They're not. They're the same way that bird scutes are, where they're not feathers but are feathers. I'm not going to go into crocodile integument, but everything with things that keep them warm are warm-blooded. Not everything with scales is cold-blooded. You may see this in crocodiles, one, but crocodiles also have other ways to do that. Crocodiles are also weird because crocodiles can kind of turn themselves cold-blooded if they wanted to.
Mm-hmm.
Because they can hibernate, and then they can make their metabolism cold-blooded. Crocodiles have a weird way of actually changing their metabolism depending on the environment, which is why this is a dumb argument, because some animals can change it. Sharks, actually. Yeah. Salmon sharks do this all the time. It's like one of the defining features of salmon sharks is their ability to go from warm-blooded to cold-blooded.
But so this is the thing a lot of creationists do. They will oversimplify to absurdity, is what I call it. They'll take a complicated situation and hyper simplify it to make a point. Because that's the only way they can support their arguments.
Yeah, the issue
because if you acknowledge any nuance, everything crumbles.
Basis in modern science. This is a children's book from the 60s.
Yeah.
Anyways,
well, I'm not going to say it's his only source, but it was kind of funny that he brought it up as like
a primary source
of what a reptile is.
Yeah, I guess.
creationist. So I've those who believe the Bible, those who don't, all the science experts I can. I've asked this in my classes. I've asked this of animal experts. Every one of them, whether they believe the Bible or not, whether they believe evolution or not, I've asked, can you be cold-blooded and have feathers? Do you have to? Every one of them, without exception, have said, no, you have to be warm-blooded to have feathers. So for Jurassic Park, they have to make all their dinosaurs be warm-blooded.
I just don't believe him.
I do, for reasons. You know why? Because the scientists are probably saying, all of the creatures that have feathers are warm-blooded, which then he oversimplifies it to be no, because technically, yes, there are no cold-blooded creatures with feathers ever, because feathers is one group of animals that are all warm-blooded. See the issue with this argument? It's why he has a point, but he doesn't understand the answer people are giving him. He's thinking of this.
Here's the thing. Apparently, he has an education in paleontology. I think he knows, and he just deliberately misrepresents it.
I don't, because the way he's talking sounds like, you know what this actually might be? It might be he has a thing in paleontology, and then like this might. I'm gonna say this. This might be the kid brain in him of being like, well, they're So there are some people who, while they're very smart people, they are very dumb when it comes to certain things because they learned it as a child from someone they trusted or believed and cannot get over that hurdle despite being very smart. And since he mentioned my uncle gave this to me, it could literally. I don't want to psychoanalyze people, and I don't. Yeah. I like giving people the benefit of the doubt, and it might be that his uncle, who's, let's say, is a creationist, was like, "Here, Timmy." I don't know his name.
His name is Ryan Cox.
Shut up! They weren't ignoring him. It's right there. Here, Ryan. Here's this book on animals, and that book on animals from someone he looks up to said all reptiles are cold-blooded, and then he learned that dinosaurs are reptiles, which even that.
I don't know. I think he's just deliberately misrepresenting. I just found it funny that he pulled out a kid's book to support his argument.
But yeah, again, it feels weird. I also, actually, before we continue, you can like the Bible. You can be religious and be in paleontology. Hell, the picture of Deinonychus from earlier is drawn by a famously very religious paleontologist. Bob Bacher is very Christian. Very, very Christian.
Here, I will be right back.
Okay. I get to entertain you guys. Let me open the chat because I don't have it open on my end. That's also true. None of the dinosaurs in Jurassic Park have feathers. That is true, actually.
Okay, I'm back. Sorry about that. Yeah, that's true. None of the dinos in Jurassic Park have feathers. He's gonna pick on them, like talking about the Dino-Bird connection a lot. Because Jurassic Park does support that birds are dinosaurs, because Jurassic Park, well, it has flaws. Crichton did a lot of research.
Yes. Also, as someone who owns birds, and specifically owns birds that do not fly very often, if you own chickens or you own turkeys or like if you own ground fowl, quails as well, and you just watch them move, you immediately understand the connection between birds and dinosaurs. The way they move, the way it's very weird. I'm
not going to pull it up because I've already showed it a couple times in this series, but I have played the chicken with a plunger video.
Yes. Chickens are very funny animals. But you can tell that this this is something else compacted down and then evolved into it. This is probably a lot better with like secretary birds or birds that stay on the ground but still have wings. I don't know. Hell, maybe flightless birds. I haven't been around ostriches and emus enough to say that, but even the way they walk and the way they act is, it feels ancient. It feels like something ancient. It's very interesting. And I own chickens. So it's just a weird argument, but I guess.
I will say he has art. Earlier in the presentation, he talked a lot about anatomy. It was just getting a lot of the anatomy. Again, pretty sure deliberately wrong. But he does a lot of arguments
Of course,
in this. But we shall continue.
So they can have feathers and turn into birds. What does the science support? Well, there's some unique traits found with warm-bloodedness. 99% of warm-bodied creatures have these little things in their nasal here called nasal turbinates, made from the concha bone. It's an incredible thing that we have because if you go outside, you're warm-blooded, like humans, we're supposed to be around 98 degrees, but the air is only 50 degrees outside, or maybe it's only 40 degrees or something like that. When you breathe it in, that concha bone senses that, and it's supposed to change the temperature of the air to be the same as your body by the time it hits your lungs.
So, by the way, all living vertebrates have this.
All living vertebrates have turbinates?
Yeah. Yes. So, olfactory turbinates are found in all living tetrapods. Because you need them to have lungs.
You know what else?
Respiratory turbinates are found in most mammals and birds.
You know what else has them?
Dinosaurs, yeah.
Stegosaurus.
Yep. Oh, really?
Yeah, apparently they've been found in Stegosaurus.
So by the way, let me see here.
Yep. CT scanning the fossils of a Canadian pachy called Stegosaurus revealed these internal structures in unprecedented detail, including scrolled olfactory turbinates in the back of the nose.
Hey, by the way, you know what mammals don't have these?
What?
So there are actually quite a few birds and mammals that don't have these. Ratites don't. Most seabirds, so albatrosses, petrels, shearwaters, all falcons, all falconiforms do not have these, and anteaters, bats, elephants, whales, and most primates do not have this. We are weird that we do in primates.
Huh.
Great apes do. But elephants, anteaters, bats, and whales do not have them, or they're very, very reduced. Most primates had them, or they're very reduced. Humans have them very reduced.
So you're saying this is not an indicator for warm-bloodedness in an animal?
No, this is no. You know what this is an indicator for?
Being
You
a
warm-blooded
vertebrate?
and having a good sense of smell.
Well, I just don't think it's an indicator for warm-bloodedness.
It's not.
You use your nose.
So what it's for properly is very weird because okay. In animals, this is the main thing it is used for is increasing smell in an area and to extract heat and moisture to prevent the desiccation of the lungs.
Mm-hmm.
So you may notice the animals that don't have these are animals that either usually live in are are usually animals that live in or around the water. So whales and most open sea birds, because they don't need this. And things like elephants, bats, anteaters, which evolved in very wet climates initially. Same with primates and falconiforms and ratites. These are all animals that probably started in a very humid environment or went to the sea or are heavily editing their nose. They all, if you heavily edit your snout from the basic mammal plan of dog or cat,
Or an
you
elephant.
end up losing this. Any editing in the face structure, you lose this. Basically,
Because they're small, squishy bones.
yeah, it's probably why falconiforms don't have it because they heavily modify their face for predation.
So all this to say, Ryan, you're wrong.
Yeah, basically. Also, that energy use thing shows as a spectrum. He's using it as an example as to why dinosaurs are in the croc side.
Yeah, when the dinosaurs should be here. Too.
Well, I think some of them should, but I think like sauropods are probably right where they're supposed to be. I don't.
No, remember the body temperature for Brachiosaurus? That thing had a bird-like metabolism.
That's fair.
It's not only the it's not the
Oh,
only sauropod to
also,
have
by
the
the way,
elevated body
Stegosaurus
temperature either.
Stegosaurus isn't the only dinosaur to have these.
I'm not surprised. I just found it funny that it was in a pachycephalosaur.
Cychania has these.
Cychania.
Yeah.
Hmm.
Yeah, Cychania.
Oh, I wonder if Tarkia does.
Ooh, it might.
It's got that big schnoz.
Actually, hey, you know what's funny? Mentions so paleontologist John Rubin ever argued there's no evidence of nasal tuberculates in dinosaurs. All the dinosaurs they examined. Oh, actually, that's interesting. All dinosaurs examined have nasal patches they claimed were too small and too short. So dinosaurs could not have sustained the breathing rate required for mammal-like or bird-like metabolic rates. Their lungs dried out. However, objections have been raised against this. So he is technically right. There are arguments that large dinosaurs did not have this because they would have dried out their lungs if they had this. They would have been. So there is arguments for his argument by actual paleontologists. John Rubin is the main person who says this. He's someone who questions that birds come from dinosaurs.
Oh, interesting.
Oh no. Okay. So sorry, what? So one, he thinks Longasquama is the original descendant of birds. He thinks that dromaeosaurs, all of Dromaeosauria, aren't dinosaurs. He thinks Longasquama became bird, then became Dromaeosauria, then became bird. So all dromaeosaurs are actually very specialized birds.
Okay, so the idea of dromaeosaurs possibly being okay.
It's a weird argument, but I could see logic-ish.
Okay.
All
Interesting.
So yeah, he thinks he still thinks birds came from reptiles. By the way, he thinks that he thinks like cold-blooded reptiles like Longasquama, like diapsids. He still thinks dinosaurs are warm-blooded. He just doesn't think that birds came from them. His argument.
He's in the same same boat as like Fiducia.
I think he thinks that dinosaurs, if they had metabolisms like mammals or birds, and the way we breathe, they would have dried out their lungs.
Okay. So here here's a scan of Tarkia's skull.
I don't have access
Sorry,
to his
just
continue. Yes.
okay. Sorry. Here's a scan of Tarkia's skull, and they're not calling them definitive turbinates, but possible turbinates in the skull. It's labeled turb here. I think it's a particular part of the yellow mass in the skull, like down here towards the front. So yeah, Tarkia, the ankylosaur with the huge nose. Which I love that it has an air conditioner for a face. I love Tarkia. Anyway, what do you got for us, Ryan?
So I need to go. I hope
Really-
I was very helpful.
It was nice to have you, Dom. Hope you have a good evening. Hope you have
Yeah,
fun.
I do. This man is insane, and I think the paleontologists you speak to are people. I don't want to be mad at John Rubin because that's actually a very interesting idea that all dromaeosaurs are actually just flightless birds. The entirety of Dromaeosauria are flightless birds.
Well, I think he said somewhere like he studied under Curry or something.
Curry is on one of the papers that Rubin wrote.
Huh.
So that
Interesting.
might not be which would put more credence that I wonder if this man is connected.
Mm.
That I'm sure that's not related. Anyways, I'm gonna hop off. Good night.
All right. See you later, Dom. All right. Well, we're going to get back to Ryan here in a second. First, I will say we have 18 people watching, and I want to say thank you for the folks who stopped on by tonight. Hope you're enjoying the show so far. We're learning animal facts and proving Ryan wrong on every single point so far, I think. I don't think he said a single thing about dinosaur anatomy or lifestyles that has held up scrutiny. To no one's surprise, I'm sure. But if you're liking the show, please do like the stream. If you could subscribe, that would be appreciated. And if we hit our super chat goal for the evening, we will be taking a look at some dinosaurs from a Jurassic World game, which should be interesting. There's some odd dinos in there. Anyway, continuing.
Cold outside and you take a breath, kind of your lungs kind of restrict a little bit. You feel that in your lungs, right? Because it's a little too cold. It's too cold for the constable, for the nasal turbinates to be the respiratory turbinates to be doing what they're supposed to do, to that extent. It also monitors how much moisture is in your body. So when you're breathing and everything, you don't dehydrate yourself. Just an incredible piece of biomechanical engineering from our incredible creator God.
Okay, so just for clarification, he's talking about these really delicate scrolls of bone in the nostrils. That just like squiggles of bone in the nose. Yes, they do help to humidify air before it reaches the lungs. It increases space for olfactory receptors. Like, it helps you smell and it helps you breathe better. It's not some wonder of biological engineering. It is a wrinkle in the nasal passage. They are wrinkles in the nasal passages. That is what they are. Ryan.
Warm-bodied creatures have that. Guess what?
Yes, and they can break super easily because they are, like, we call them scrolls of bone because of their shape, but they are paper-like. And also in humans, they get infected and inflamed like constantly. Let me get a picture of the bones. Here. So I'm gonna pull up a drawing here. So this is a picture. This is a horse's skull cut in half. So this is the nasal passage. These kind of webs of bone over here, those are the turbinates. And they're very large because horses have very large nose. sorry, horses have very large noses. You can see, I think you can tell how thin these bones are. They break super easily. They get infected super easily. They're a great place for parasites to sit. I know that in deer, there are species of flies that will crawl into a deer's nose and lay their eggs in their nasal turbinates because the deer can't get them out and they just sneeze out maggots. It's really disgusting. These are complications of the air passages. They are not divinely inspired. They are not.
It has never, ever been found.
And yes, as DM Wing says, it can be a beautifully engineered feature from your glorious creator, and evolution can still be true. That is true.
In any dinosaur, those types of respiratory turbinates.
Well, as Dom helped to illuminate there, we have them in at least 3 dinosaurs. 2 ankylosaurs and a pachycephalosaur. The head bonkers.
In a couple of them, they found olfactory ones where they can, for smelling, but they've not found that. Not even a hint of where they could have attached in the nose. In fact, the nose isn't designed for that at all. Rather, everything we see about these creatures shows they were cold-blooded.
Okay, let's see. What is his source here? Okay, let's see what this source says before we look it up. But I'm curious what he's going to say this source says.
Attached in the nose. In fact, the nose isn't designed for that at all. Rather, everything we see about these creatures shows they were cold-blooded. Highly active, much more active, but still cold-blooded in their thermal regulation. This study done in 2020 in the Anatomical Record showed that those top supratemporal fenestra, okay, so these two up here, these are just like what are found in crocodilians, and it's used for monitoring the air around them so they can adjust to it and find the shade or let off some.
Those are muscle attachment points. Ryan, I don't know what you're talking about. I'm going to rewind a little bit so we can see that article. God, that's a mouthful. Just give me a second. I gotta... Oral fenestra of archosaurs and their significance for interpretations of... Okay, that should be enough of the title to find the paper. Let me look it up. See if we can find it. Okay, Yep, by Casey Holliday and colleagues. Oh, and Lawrence Whitmer. Okay. It's coming from the Whitmer lab. Oh, wow, their abstract got cut off by abbreviations. That's interesting. Wonder if this is an official copy. Okay, so there is a lot of, how do I put this? There's a lot of big words in here, so just breaking it down. This paper is analyzing the holes on the top of dinosaur skulls and comparing them to the top of the holes and skulls in living archosaurs, so birds and crocodilians, and trying to figure out what those holes were used for. The paper suggests, I don't know how well this is supported, but it suggests that in dinosaurs, broadly, those holes were used. I'm just trying to get a good picture. That those holes were used for a little bit of fat storage and blood vessels. So maybe a way to help cool the animal or detect things. So yeah, could probably help detect sunlight, I guess. But it could have been used for a lot of things. Let's see. What is this figure? What is this figure attached to? Okay. So here. Okay. So here's a simplified illustration. Oh, wow. Okay. This is a simplified illustration of what's going on here. So this is for the dinosaur Herrerasaurus, which is an early dinosaur. Might be on the theropod line, might be on the sauropod line. I think we still go back and forth on it, or if it's some weird offshoot. But the classic interpretation here is that it's like just muscle all the way through. Like this hole would be fully filled by muscle that would go down to the jaw, is the classic interpretation. Their results suggest that the top, here, you can see it here, especially if I zoom in, that the top of the hole in the top of the skull, like the very top, would have been like blood vessels and fat. But most of it would have still been filled by muscle, apparently, if I'm understanding this right. So it's just like a slight reduction in muscle mass, I guess. And according to this paper suggests that it could have been the basis for maybe something on the top of the skin, or like something that would have predisposed a lot of dinosaurs toward growing features on their heads. Like they would have already had a lot of vasculature in place, which might actually hold some weight, because a lot of dinosaurs develop horns or crests above the eyes in this general area, which is neat. It's neat, but this just seems to be an archosaur thing. Because, yeah, look here. Are they differentiating? Okay, yeah, that is what they are saying. They're not saying that this means that dinosaurs were cold-blooded. They just have this ancestral feature. That's all that it's saying. And it might have predisposed them towards like cranial ornamentation. Okay. So a couple things to go over. First, the chat is lively, and I appreciate that. Rosny is asking if I've seen videos of botfly larvae being removed. Unfortunately, I have. Do yourself a favor and do not look that up. It is disgusting. Petite Flower, I have seen it posed that just the amount of muscle on large dinos would have made a lot of heat. Yeah, they're huge animals moving around. Muscles acting generates heat. Yeah, I probably would have made a ton of heat. There can be disagreement among scientists over whether dinosaurs are endo or exothermic, but none of that makes creationism true. That's true. I don't know any paleontologist who's still holding to the old dinosaurs are cold-blooded idea. I don't know of any. There might be someone out there, but like all the data we have from even just anatomy for dinosaurs suggests they were very, very warm-blooded. Like in the range of mammals and birds. Anyway, what were you saying, Ryan?
Anatomical record showed that those top supratemporal fenestra, okay, so these two up here, these two up here, these are just like what are found in crocodilians, and it's used for monitoring the air around them so they can adjust to it and find the shade or let off some heat if they needed to, that kind of thing. Just like other reptiles today, as you can see in the, but it's not like birds. Birds don't have that. I think it's kind of funny.
So again, this just seems to be an ancestral feature of archosaurs and maybe sauropsids in general. It's just a feature they share. Synapsids have a parietal eye. Like, synapsids ancestrally had a third eye in the middle of the skull. They just have that. It's closed in humans. You still have your pineal gland, which is attached to that whole system that used to be there. That doesn't mean we're cold-blooded. And also, birds... Does it say that birds don't have this anymore? So the thing is with birds is birds do a ton of weird crap to the skull. But at least going by this, it looks like it has a similar thing going on to what Majungasaurus has over here. It's just been migrated because birds do really weird things with their skulls. But in general, the same kind of structure seems to be there. So I don't know where he's getting that from, but it seems to be present in birds too.
Okay, so they made this little caricature of what it would look like, you know, with a T-Rex. No, this is not an actual infrared picture taken of a T-Rex. This did okay, but also did
that come from the paper? Oh, that isn't this paper. Oh, that's cool. This is something by Brian Ang. Brian Ang is a really cool artist. That's really cool. Sorry, I'm just geeking out because that's a really cool illustration. But yeah, it's cool. And oh, look at that. So the little hot spots up here, oh, those correspond to the fenestrae. That's really cool. Oh, and the bird's face is hot down here because that's where its face would be. Or that's where the corresponding holes would be. That's cool. I like that illustration. Thank you for showing that, Ryan. Genuinely, that's cool. See, they have any other cool art in here to show? Okay, no, they don't have any other cool art in here to show, but that is neat. I love when paleo art gets informed by science like that.
Design of their nose, it's too thin. It's too narrow a passageway to get the air through it that they need in order to be warm-blooded, to get the air moving in to keep things ventilated. Just like a car needs a radiator to keep from overheating, so you need enough airflow to keep yourself from overheating if you're a warm-bodied creature. This study, published in 2023 in the Royal Society of Open Science, said, quote, "Here we found that the size of the nasal cavity relative to the head size of extant endotherms, so warm-blooded, is larger than those of extant ectotherms, cold-blooded, with that of the dromaeosaurid velociraptor being below the extant endotherms level. The result suggests that a large nasal cavity accommodating a well-developed respiratory turbinate," remember that thing up here, "is primarily important as a thermal regulation apparatus for large brains, characteristic of endothermic birds and mammals." Like birds do. See, birds have that.
Okay. Let's go ahead and look up this paper because it sounds like an interesting paper. And it does not sound like it's saying that Velociraptor was cold-blooded. It sounds like he's oversimplifying, again, because that's what Ryan does. Let's see, who's the author? Process. All right, let's give this a whirl. All right, got the paper. Let's read the paper. Let's look at the paper. What the paper gonna say? Is the paper gonna say what he's saying? I don't think it do. I don't think it gonna do, I should say. And okay, here we go. Elucidated based on natural structures by Tada et al. Okay. Okay, that's very interesting, Ryan. That's very interesting, Ryan. Why do you stop your quote from the abstract there? Because that's not where the quote ends. Okay. Here, I'll just go ahead and read verbatim here. The result suggests that a large nasal cavity, accommodating a well-developed respiratory turbinate, is primarily important as a thermoregulation apparatus for large brains, characteristic of endothermic birds and mammals. And the nasal cavity of Velociraptor was apparently not large enough to carry out this role required for an endothermic-sized brain. In addition, a hypothesis that the enlargement of the nasal cavity for brain cooling has been associated with the skull modification in the theropod lineage toward modern birds is proposed herein. In particular, the reduction of the maxilla and derived aviolans may have coincided with acquisition of the avian-like cephalic thermoregulation system. Okay, so translation. This paper is saying, hey, as we go through the dinosaur lineage going towards birds, there are changes. We're going to look at Velociraptor and see if it had the same brain cooling mechanisms that birds have. It didn't have that. So that trait was acquired along the way. This is particularly for the brain, not about being an endotherm in general. This is specific for the brain. Okay. Okay. Yep, so here's the possible airway for a velociraptor, which is smaller than you see in a bird, which is not really that big a surprise, because here's the thing: Velociraptor is a dromaeosaur. It's on the line towards birds, but it's not all the way to a bird. And this is a neat way to do a family tree here. So coming from the bottom up to the top, we go from slightly less birdy things to more birdy things. And it's showing a change in the skull leading towards birds. It's showing the Velociraptor here is intermediate between Archaeopteryx and Sinraptor, which is, think like an Allosaurus. Like, this is an interesting paper. It's just saying, hey, Velociraptor has a smaller brain and it has a smaller airway. So it didn't have the cooling mechanism that birds have. That's what this paper is saying. It's not saying that Velociraptor was cold-blooded. Also, yes, if Dapper was on, we would take a drink for quoting from the abstract. And yeah, shock that Dromaeosaurus had different features from modern birds. Yeah, like, okay, Velociraptor is very bird-like. It is very bird-like. It doesn't have the same adaptations as birds. That's not a surprise, Ryan. That's not a surprise, Ryan. Oh, boy. Oh boy. Fitz is taking a drink anyway.
But reptiles and dinosaurs don't. And the nasal cavity velociraptor was apparently not large enough to carry out this role required for an endothermic sized brain. So
it was not large enough to support a big brain, or like to cool a big brain if this was the only mechanism it had. Again, this paper is saying, hey, Velociraptor doesn't have the same temperature control feature we see in birds. It must have evolved along the way.
So here it is. There's Velociraptor, okay, that they were looking at. And you can see there through, and the way they highlighted that there in the yellow, it's very narrow. And they compared that, in amongst other creatures, to an alligator and an ostrich. Can you see the difference? Yes, quite a big difference. This is our Dromaeosaurus. So this is our Dromaeosaurus back here. This is the skull of it. The skull, specifically of Dromaeosaurus, is what's most preserved of the Dromaeosaurus, a type of raptor. Raptors are usually divided into two main categories, Dromaeosauridae and Velociraptoridae. Dromaeosauridae is usually...
So that... No, one, that's not true, and two, it depends. So, how do I do this? So we have our big category, right? We have our big category of aviolans. Aviolans are things that are close to birds, but not quite birds, and birds. Birds are within avialae. Within avialae, you have Dromaeosauridae. That is a family within that group. Dromaeosauridae is generally divided into three, not families. I think it's three tribes. Velociraptorinae, Dromaeosaurinae, and Microraptorinae. There's a fourth category called Unenlaginae, which is a problem child. We'll say that. Yeah, it's not Dromaeosauridae and Velociraptorinae. That's just wrong. I will say there have been some interesting recent developments. At least one of those tribes may turn out to just be a group of weird birds. Like, actually birds. Because here's the thing. Dromaeosaurs are so close to being birds that they might be within the birds. Dom brought up this hypothesis earlier. I know it has some supporters. I don't know how well supported it is because I haven't looked into the papers yet. But if it's true, all of these bird-like things may genuinely be birds, just early branching birds. And they might be the weird ones. Okay, sorry, Caden, you're right. Dromaeosauridae is within Paraves, not avialae, unless dromaeosaurids are aviolans. Again, it's a thing right now. Sorry, I should use actual words. It's a complicated situation right now because they are so close to being birds. They might be birds. Like, we're talking about groups of animals that are so absurdly closely related to each other. We don't know which is more closely related to each other. They're close.
A little more blunter nose, a little thicker skull, the Velociraptor category, a little longer and skinnier, so it makes it even worse for them to try to be more as the paper shows. And
the paper doesn't say anything about that. I don't think the paper touches on Dromaeosaurus at all. Yeah, no, the paper doesn't talk about Dromaeosaurus at all. The only Dromaeosaurid it seems to bring up is Velociraptor. They probably chose Velociraptor because it is a really well preserved skull. But yeah, no, Ryan, that's not what it says. It's not.
Yep. So this is AMNH 5356. This is a research cast of the one out of the American Museum of Natural History, discovered in 1914 by Barnum Brown, so we can use this to do scientific research. Sure enough, nothing in there to suggest any type of nasal turbinates, respiratory turbinates, and the passageway too narrow, just as you can see in the diagram. So everything points to them being cold-blooded like regular reptiles. Well, how could
No, Ryan, it does not. You're not taking into account any other features of the anatomy. You're not taking into account the fact that dromaeosaurs have an avian respiratory system that all theropods seem to have. They breathe like birds. Just because it doesn't have the specific cooling mechanism in the brain does not mean they're not birds. Or sorry, does not mean that they're not warm-blooded. They just don't have that one feature, and you're lying about it, Ryan. We've been over it several times already. Okay, I'm going to actually look up. Do we have a body temperature study for dromaeosaurids? Let's look it up. Let's look it up. Let's look on Google Scholar. All right, come on, let's open her up. I'm currently opening a paper that is 20 years old today. So we're going to take what it says with a grain of salt. Okay. Oh, great. Okay, I have to access it through my institution. Never mind. Where are we? Sorry, I'm trying to look through a paper really quick. Okay. Sorry, I was trying to look through stuff. So, I'm not finding a paper that did like an exhaustive, that did like a body temperature study using stable isotope analysis. That's what I'm trying to find. But not only are dromaeosaurs super bird-like to the point that they are consistently confused with birds, which probably says something on an evolutionary level. But anyway, not only are they super similar to birds, we have dromaeosaurs that lived in like Arctic environments. We have dromaeosaurs from Alaska and like northern North America, just all throughout northern North America and other places that would have been really, really cold, at least during some points of the year. We have dromaeosaurs like Microraptor, which is, at least at present, as far as I know, a dromaeosaurid. that could fly, like has preserved feathers, would have had a high body temperature. Like it's you can't just say they are reptiles, therefore they must be cold-blooded. It's not that simple. And this paper the paper that you are putting on screen does not support you either, Ryan. It just says that Velociraptor had a small brain, so it didn't have the big air conditioning system that birds have. Anyway, I'm going to catch up with the chat because it's been a minute since I looked at you guys, and I apologize. DM Wing, I'll bet the Dromaeosaur skulls has feature between that of birds and crocodiles. You know what? You're right. Let me pull up the thing. Where's the thing? 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 Well, there's no crocodilian on here, but what do you know? You're right. The skull features of Velociraptor. This is looking at the maxilla specifically, but there's a lot of other features of the skull you could look at. But it's just a consistent through line. Like there's a change as you go towards birds. Correct? DM Wing also said Gurren Lagann. I get that reference. I have never finished it. I've never finished Gurren Lagann. I've tried twice, just couldn't get into it. The music's incredible though. Let's see. Of course, how we create categories and where we draw the lines is ultimately arbitrary and up to human choice. I would say that's true to a degree. When you do phylogenetics, there are ways to quantify features that help elucidate evolutionary relationships. Like that's a thing we have been doing for decades upon actual centuries now. Like you can determine like this is more closely related to this, and genetics help. But ultimately what you call something and if it's in a particular group or not, what groups are within what groups can to a degree be arbitrary. And yeah, transitions get more smooth the more data we collect. The curse of having lots of fossils, which is a good curse to have. Hello, Grayson. I hope you're doing well, man. It's been a little bit. Yes, birds have a sexy unidirectional respiratory system. That's true. Birds and dinosaurs. Okay. Yeah, caught up with the chat. Hope y'all are doing well. We are one super chat into our goal, so we might not be looking at Jurassic World Evolution stuff today. But that is okay. That is okay. We'll probably stop the stream at 2, maybe 2.5 hours. We'll have to see. For now, what do you got next for us, Ryan?
They'd be more active than reptiles today. Depends on your environmental conditions. What if conditions back then were much more readily conducive to being more active, as well as food supply and things like that? Then could they be a little more active? Because, I mean, they are their own category. And we're not saying, and are we saying that?
Okay, so dinosaurs lived in every environment on Earth. Velociraptor lived in a desert. Dromaeosaurus would have lived in, let's see, Dinosaur Park Formation would have lived in a very productive woodland. We have troodontids from Alaska that would have hunted in a polar forest. We have dinosaurs in swamps. We have dinosaurs around the ocean, partially in the ocean, depends on the species. We have dinosaurs in every environment. And many of them would have gotten to freezing or below freezing. And they were in areas that didn't have crocodilians, at least our modern crocodilians, because it was too cold for them. So No, how active they were was not dependent on their environment. They had an avian type thermoregulation. Or sorry, they had avian like body temperatures. I'm sorry you don't like that.
Triceratops was as active and running around as a raptor might have been. No, in fact, even then, you know how raptors, they show them running as fast as motorcycles, or faster than motorcycles in Jurassic World. Well, the better understanding is maybe 25 mile an hour with maybe a quick sprint of 40, and then after that, they have used up their energy, and they're going to have to rest, just like a reptile today can move very fast, very quickly. But then once it's used, that it has to stop and wait and get some food, some sustenance, and then.
Okay, so that's a few things mixed together. First off, the Jurassic Park series has not been a paragon of science since the first one, and even the first one had problems. Yes, Velociraptor. The Raptors. I'm just going to call them the Raptors. In the Jurassic Park series are said to have cheetah speed, 60, 70 miles an hour if they ever got out in the open. Real dromaeosaurs, yes, they would have been slower. They were not track stars. Depending on which one you're talking about, like 20 to 30 miles an hour might be a good estimate. That might be. Very much depends on the genus. And troodontids actually seem to have maybe been built for speed, so maybe they were the faster ones. Anyway, the reason why many modern reptiles, at least many modern lizards, need to stop after a burst of movement isn't necessarily because they have a slow metabolism. It's because their breathing system is tied to the system that lets them move. They cannot breathe and run at the same time, at least for a lot of lizards. Like, they literally cannot breathe and run at the same time, so they need to stop or they will pass out. And that can actually happen to some anole lizards. Like, if you ever chase those, if you live in a tropical area, sometimes they will pass out if you chase them because they can't breathe and run at the same time. Dromaeosaurids didn't have that issue because they had a bird-like respiratory system. No, they didn't have the big nasal cavity that modern birds do, but they had a unidirectional way of breathing. We know they breathe like birds. Okay. And Sydney Raptor says Velociraptors are the awesomest. You are kind of biased. I will say you are kind of biased. And we have a guest. Hello, Grayson.
What up, dog?
Not a lot. Working through a presentation by Ryan Cox. Are you familiar with him?
I'm not, but I was watching a little bit. When I came on, you were looking for like an isotopic analysis study of like dromaeosaurid, like body temperature, basically. I managed to find one for a close relative of dromaeosaurs. If that's acceptable for a troodont?
That would be acceptable. Can you share it?
The name, yeah. Okay, let me put it in the private chat here. That's the name of it. I should just put a link, but I don't know what website you were able to read the full thing on. But here, I got a link.
Here.
But yeah, I mean, it comes up. I think not quite as warm as birds, but like, transitional, obviously. So.
Yeah, that's not much of a surprise.
But it's one of three. It's one of three species I think that they look at in the study. But it kind of surprised me that nobody had done specifically dromaeosaur. But I guess maybe there's like less remains from dromaeosaurs compared to other like titanosaurs and things like that. I think that there's a couple on Triceratops from what I was looking at, but I think what is this 2020 this study? If you but yeah.
I'm looking through it right now. Where are your results? Sorry, had it and lost it. There it is.
Yeah, so there's the theropod in pink there.
Yeah, well, what do you know? It's right around with birds.
Mm-hmm.
Yep. Well, that is very much appreciated. Thank you.
Much obliged, much obliged. And I figure now we'll be delving back into the creationist depths, the backwaters here.
Yes, unfortunately, yes. I will save that paper though. Let me see who's the art or who's the. I'm not familiar with the authors. Interesting. I know a paleontologist who was working on the troodontid eggs from Egg Mountain. I'm surprised it's not him.
It looks like Yale affiliations from what I'm kind of, or let me see. Yeah, Yale. A lot of guys are Yale guys.
Okay. Interessante.
So what would you say that this guy's like central thesis? What's his argument here that he's trying to push forward with bad science here?
Birds are not a kind of dinosaur, and dinosaurs were cold-blooded lizard things.
Oh, okay. Well, we just debunked the first one of those, or the second one rather quickly, just right off the bat, coming in with the old 1-2 with the link.
Yeah, again, much appreciated. But he has been wrong on, I think, every point so far, at least when it comes to dinosaur anatomy and lifestyle. Or at least he's wrong in some way. We've got him misquoting sources. Like from the paper that's on screen right now, he quoted the first 3/4 of the abstract and then left out the last quarter that debunked.
Oh, you mean like usually the part where they like lay out the problem before putting forward the solution that they found in their study, like that part?
Kinda, yeah.
Yeah. I love a good quote mine in the morning.
Well, if you want to stick around, I'm sure he'll have plenty more egregious things to say. But
Sure
that
thing.
is up to you.
Let it roll. Laissez le bon temps rouler.
Has to use the sun has to bathe in the sun to get that energy to activate their digestive system. So you see, no problems with them being cold-blooded, not at all. Since we're talking about them in the movies, and this plays into their ancestry as well, you always see them with their hands like this. When I go and I talk to young people, VBS's church camps, like, all right.
God, those are some ugly raptors. I'm sorry, but ugh.
I can. What movie is that from? Is that supposed to be from Jurassic Park? Because like the title is specifically movie raptors.
I mean, this whole section is just him talking about Velociraptor, just talking about dromaeosaurids in general. It's honestly kind of disjointed, but that's kind of the style of his presentation. I have no idea what that is from. It looks like a early or mid 2000s webpage. That's my guess. But I will say this is one thing he is right about. The raptors in Jurassic Park, well, all of the dinosaurs in Jurassic Park have their hands positioned wrong.
Really?
Yeah. So I'll make myself a bit bigger here to illustrate it. So in Jurassic Park, the T-Rex and the raptors have their hands like this, right? Kind of like that. We call them bunny hands. They could not physically do that without breaking their wrists because trying to remember how far back it goes. Dinosaur wrists are not very flexible. Their ankle and wrist joints just aren't. Their hands could not do this. They had to be rotated inwards like this. For most of them, if they tried to do this, would break a bone in their wrist. I would have to find the study, but there was a study on Velociraptor in particular that showed its hands could do this and this. That was like their range of motion.
Mhm. Wow, it's like it's giving you a little hug.
We say they're clapping, not slapping.
I like the little death hug with claws.
Yeah. Although there's, I think, one group of dinosaurs that did evolve to be able to put their hands like this, and that's the duck-billed dinosaurs, weirdly enough.
I could
They
see it.
evolved to be able to pronate their wrists. No other dinosaurs could that I remember right now.
That oddly makes sense to me, though. I see that.
Hadrosaurs are weird. People think of them as like a default dinosaur, but they are weird. They have so many strange adaptations because they evolved to be able to walk across continents.
Don't their teeth have like the most surface area of like any teeth ever evolved or something?
I don't know about that. I know that they used the entire tooth and ground them down into dust. Hadrosaur jaws are a nightmare. They evolved to be able to chew, which almost no other dinosaur can do. They turn their teeth into batteries of cheese graters. If that makes any sense. And their teeth themselves are on a conveyor belt that is just continuously being graded upwards. Like they literally chewed through their teeth like crazy, and they could eat just about anything. We have coprolites from hadrosaurs that show them munching on soft things, hard things. They ate rotten wood. They ate the crustaceans and mushrooms in the wood. They probably would have eaten bone. They probably ate bones if they could fit them in their mouths. Like they were the locust bison of dinosaurs, is how I would describe them.
Terrifying locust bison. Wow. Yeah, I won't be able to look at them in the same way.
It's horrific.
So we talk about dinosaurs. Let me see your dinosaur hands. Show me your hands. 2 if you're a tyrannosaur, 3 if you're a raptor or an allosaur. And they always go like this. They have their hands like this. You can see in the diagram there, like they could go up and play the piano. Problem: no dinosaur can turn their arms, whether they are walking on all fours or just walking on 2. None of them can turn their hands like this. In fact, here's what they can do.
Again, I think hadrosaurs can, but I could be wrong about that, but I think they can. Also, yeah, you know what, Rosnia, you have a better analogy. Hadrosaurs are goats.
They can stick their hands out straight. And so if I got my fingers out like this, they can go out like this, back in like this, back out like this, up and down like this. They can do all those things. The only thing they can't do is go like this. They cannot pronate their hands. They can supinate their hands because of the anatomy, the way they're.
At least Velociraptor could supinate. That's when your palms are upward. So I'll just show my hands quick. So I can't put my hand back like a Velociraptor could because they have a special joint in their wrist that lets their hand flop. But it could go like that. Basically. Boop. And yeah, so artist errors refute all of paleontology. Gotcha. That's about on par for everything else he's said so far.
Elbow is attached to their arm, okay? How the ulna is anchored in the center of it and the way the wrist is designed, they can't do that. So the understanding by paleontologists, this is how they teach this, is that dinosaurs were clappers because they can have their hands like this, but not slappers. They can't turn their hands over and slap their knees. Just one of those. Yet, why then are they like this? Why are they like this? Best understanding I have is in 1993, the raptors, who are super smart and hunt in packs, because we find them hunting in packs in the files. No, we actually never find raptors with other raptors. We'll find other dinosaurs, tens of thousands of dinosaurs buried.
Wrong. That's just completely wrong. So the raptor that the raptors in Jurassic Park are based on is Deinonychus, which is famous for being found in bone beds. We have at least 2 instances of multiple. I can't find a picture of it, but we have at least 2 instances of multiple Deinonychus being found surrounding a corpse of a larger dinosaur.
So does that imply that they were like hunting in groups?
People go back and forth. Sorry, paleontologists go back and forth on it.
Oh, wait, we can't call those people.
Of all of the dinosaurs that could have hunted in packs, Deinonychus has the most evidence for it, is what I would say. Or at least associating with each other. We can't say for sure that they hunted together. They might have been like swarming a body or something, but we do have multiple of them dying in the same place at the same time. And again, at least 2 different instances. We also have, so we have this dinosaur here. That's Tenontosaurus. Tenontosaurus, in the formation it's found in, is super commonly associated with Deinonychus teeth. Like to a statistically significant degree. And it's almost always found with more teeth than one Deinonychus could lose in a single meal. Or than one Deinonychus could lose at a time. So they were probably being fed on by groups of Deinonychus, but we're cautious about saying that a group of Deinonychus killed a Tenontosaurus. It definitely has the most evidence of any non-avian dinosaur that I can think of, though.
Well, I'm going to choose to believe it then.
Yeah, you can. There's nothing specifically refuting it, and I think it's possible. Paleontologists are just cautious about stuff like that. But yeah, of all of the dinosaurs to pick with this, no. We have evidence for it with Deinonychus. At least possible evidence. Dear.
Together, but raptors we don't.
We also have trackways of dromaeosaurids. I forget where they are, but we have at least one dromaeosaurid trackway that's, I want to say it's at least 4 individuals all traveling in the same direction. And they're deposited in the same layer. That doesn't mean they were there at the same time, but they were traveling in the same direction within a close time frame.
Yeah, that's close enough for me. Compounded with all those 3 lines of evidence, I'm just gonna go ahead and be picturing a little group of Deinonychus hunting down their prey. That's so cool.
You can. Weirdly enough, another dromaeosaurid that, 2 out of 3 of the dromaeosaurids here have been found in multi-individual blocks, because we have one for Utah raptor. It's actually called the block. There is, if I can get a picture. So we have a quarry where there is like one iguanodontid, so one herbivorous dinosaur, and I want to say at least 3 Utah raptors just embedded in this big chunk of quicksand.
Oh, sick.
Yeah. And I think it's 1 or 2 adults and several juveniles. It's a 9-ton block of sandstone. So thousands of bones from Utah raptors, and at least 2 iguanodont dinosaurs, maybe some other things. Yep, quicksand. Yeah, it's really cool. The block is still being worked on. Like, it's still being dug out. It's awesome.
Yeah, when you were talking earlier about basically saying that dromaeosaurs might be part of avialans instead of just like paraves, it reminded me of like Genuine Long, I think is how you pronounce it. Zhen Genuine Long. And like I think I sent it to you, and I was outraged that all of my dinosaur loving friends had let me go on my entire life without knowing of this dinosaur's existence. And it literally is like a dromaeosaur with like actual wings, like not just
Yep. This one?
yeah, like not just like feathers, like but wings. Like that is like a straight up like bird wing. And so if this is this thing, but it couldn't fly. Like the wings are not large enough for its body to fly. So it's like raises the point. Like
At least not as an adult. Juveniles might have been able to.
But it like raises the question basically, like did this thing's ancestor have wings? Like is this like a state that it's inherited, in which case like it could be close to like a shared ancestor of avialans in general, could be, because I mean those look like straight up bird wings.
So it's complicated. There has been a relatively new hypothesis put forth that like paraves in general might just be birds that came down, or sorry, like the ancestor of birds, dromaeosaurs, troodontids, and maybe oviraptorosaurs might have been able to fly, and then 3 of those groups just came down to the ground. I honestly have to read up on it. It's a fairly new idea, but there have been things shifting around recently. Like there was a study just this year that found a group of dromaeosaurs to just be birds. Like they are avialans.
Yeah, so in which case their ancestor would have had bird wings. Like straight up.
Yeah, might have.
It's just crazy to think about. Like I hope we can get some sort of fossil of like a basal dromaeosaur. Like, I mean, I know that there's like the idea that they might be similar in anatomy to like Microraptor, right? But I wish we had like a really, really basal dromaeosaur fossil.
It would be nice. The issue is that these things don't preserve well, except in very pristine environments, because they're so lightly built. Like their bones are paper mache. I found bones from Deinonychus. They are paper with like bone webbing keeping them together.
That was after I left Wyoming, right? It was when you found that?
Yeah.
Okay.
I have a picture of me holding a Deinonychus claw in my hand.
So cool.
Do I have that? I might have that on my Discord. Let's see. Image. No, that's a different bone. That's other things.
I see Caden mention Harris Hawks. That was actually the kind of hawk that my dad had when I was growing up. like use a falconer. So he always kept a Harris hawk, and throughout my entire elementary school age, like we had one in the backyard in a little coop, and we would go like hunting on the weekends with the hawk. And Harris hawk are ideal for falconry because, like Caden mentioned, they're one of the few birds of prey that are pack hunters. So they'll more readily than other birds will adopt you into their pack.
I knew there was one kind of hawk that like hunted in packs. I didn't know that was the one you had. Are they easier to tame because they're pack hunters, do you think?
There are a number of different starter birds. I don't know. I think Harris hawks are just like one of the good varieties to start with. But I do know that they are just like more natural team hunters, so they'll more readily like work with you as a team for like hunting purposes.
Okay, interesante. I think birds are weird, but birds are also cool. I like learning about them, even though they're not my particular area of study. Also, Caden is saying he lives in the same state Utah Raptor is found in.
Oh, what state is that?
I wonder. You could try going and looking for one, Caden. Like, genuinely, you could try to go look for one if you wanted. I think the Cedar Mountain Formation is pretty widespread in Utah, though I could be wrong.
Just bring a buddy with you because it gets hot and dry, and you got to make sure you bring enough water.
Yes, be prepared. But fossil hunting's fun.
Can vouch.
But they're smart hunting in packs in the movie, and they have to open a door. And so with their animatronic ones, if their hand's already like this, they can just push it down and they can walk right in. It's my best guess as to why they're like that. And
okay, I don't have an official source for this, but the thing I've always heard is they put their hands like that because that's how that is how hawks and birds of prey hold their hands.
Yeah, I think it's just because it looks cool. Like it looks menacing.
Yeah. It looks menacing.
I mean, it's a movie.
It looks right at first glance.
I mean, movies are a visual medium, so you got to have the best visuals.
Also, I don't know if we knew they couldn't rotate their hands like that at the time, too. I don't know when that research was done. I just know now that they couldn't move their hands like that. I don't know if they knew that in the 90s. So, yeah.
Since they've seen that, they look like that. I don't. They can't do that. Their hands are always facing each other. Okay. But you see, the wrists and their arms, that's supposed to be part of their evolutionary process, as shown by National Geographic and PBS back in 2001. They published this showing, look at the evolution of the arm into a wing as the bird evolves, or as the dinosaur evolves into a bird. Okay. Yeah. Look at that progression. Isn't that amazing? Here's what's interesting about this. A colleague of ours, Dr. Charles Jackson, he went and looked this up, and I've done it since then as well. These different creatures you see on here, Sinosauropteryx, Velociraptor, Caudipteryx, Archaeopteryx, so on, they have them in an interesting order. What are the evolutionary dates of each of these? Like, how old do evolution? So, like, specifically from the Natural History Museum of London, what are their dates they ascribe to each of these creatures? So you see the numbers on the side there. Let's now assign them to their respective creature, and zoom in here a little bit here. Oh, looky here. That doesn't seem to be in order, doesn't it?
Yes, because this is showing a progression of forms, not ancestry. It's showing a progression of forms, not a progression through time. It's showing their relative positions on where they probably branched off. That is what it is showing.
Well, it'd be like, you could show a diagram of like a wolf and a dog, and like, I mean, this guy would agree that dogs came from wolves. And then, oh, but you could show it where the wolf is in the modern day and the dog was from the 1800s. And this guy would be like, oh, so his brain would just explode and he would just suddenly realize like that, like these forms can persist for much like for co-equal or like at the same time as other branches, like sister clades.
Like, evolution is a process of divergence and specialization. The ancestral state does not have to disappear for a new state to appear. They can coexist.
Yeah,
Like,
thank you for
dogs and
saying
wolves
that.
are alive
Look.
today. I mean, this is like a common creationist thing. It's barely worth addressing. It's so common, but it's still aggravating.
Well, if you
No,
don't
it
think
doesn't
about
look like that's.
Sorry.
I was just saying, if you don't think about it for 2 seconds, you're like, oh yeah, like those numbers aren't in order. But then you're like, exactly. If you think about it a little bit, it loses all logical cohesion and power.
Yeah. Also, this is unfortunately outdated. What do you say, 2001? I think he said this is from 2001. That poor Velociraptor.
The right order according to their ages. So, in how they're trying to show the progression of the evolution of the wing as the dinosaur turns into a bird, there's the youngest, the baby, okay, modern day, present day. Yeah, we'd expect that to be at the end. Shouldn't the oldest one be down at the other end? No, it's not even close to the other end. Instead, here's the baby's mama, which should be right up next to baby, shouldn't it? If we're going back to mama and then grandmama and then great grandmother and great great grandmother. And so, no, mama's all the way back there. Here's grandma. There she is at 94 million years old. And there's great grandma there at the Protearchaeopteryx, 122 million years old. And there's great great grandma at 125. And the oldest one, great 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 grandma, is where grandma should have been. How does this even happen? I don't know.
Because you're being stupid on purpose and misrepresenting the diagram. To no one's surprise.
But this is the best they've got. And it's like, what? Why? Why are they so ingrained on this? Why is it, if you even dare question this whole bird dinosaur connection, that you can be ostracized, you can be kicked out of your program, they can keep your papers from being published, which this has happened to secular evolutionary scientists who have dared question this.
Wait, like who?
He's probably meaning like fiducia.
Okay.
Like, listen, like, if you try to publish information that is either blatantly false or contradicts well-established stuff that and your stuff is not supported, it's not going to get published. I'm sorry. That's why the peer review process exists. Like, you it's aggravating. So aggravating.
Why? Something I've noticed everywhere I go. I travel the country all year long, lots of youth programs, and I'll ask them, what's your favorite dinosaur? Name a dinosaur. Name any dinosaur. 99% of the time, a young person will yell out, chicken. Chicken. It's not a crow.
I mean,
He's saying this like it's so sinister.
well, because it's the angle that creationism almost always boils down to. Like, they can convince you of this. What else can they do? Because social rah rah rah. Like, like it is I don't really have a word for it besides aggravating. I think my brain's starting to melt. But it really is. Like, it's a conspiracy theory that creationism often boils down to. Like, you have to reject. Forget it. Though I will say we have hit the 2-hour mark, which means that our super chat goal is sadly closing. And we did not meet it, so we are not going to be playing Jurassic World Evolution tonight, folks. But that is all right. I probably got a couple more minutes in me, and then I am probably done for the night. Anyway.
Not a cardinal, not a hummingbird, not an ostrich or an emu, not a penguin, not an eagle or a hawk or an owl or a raven. It's always chicken without exception. I've been doing this 8 years, 8.5 years.
Oh, yeah. Favorite dinosaur being a chicken. I don't know. I've asked that question plenty of times, and I always get a variety of answers. T-Rex is super common. Velociraptor, Brontosaurus or Triceratops. Like, I've gotten a lot of answers. Sure, sometimes someone will say chicken, but they're not wrong. Sorry.
100% of the time. I've never had an alternative. It's always chicken. When I had my family at Legoland in Kissimmee, Florida, we were going into the farm section. You're going to ride on a tractor that looks like it's made out of Legos. And right there is the thing about chicken. And the first thing it says is the chicken is related to T-Rex. Just like that. I think my best guess is chicken is the easiest to teach, to get them to remember, to understand, because this is not about the science.
Okay, it is science. Why do we use chicken as an example? Because it's a bird that everyone knows. We have chickens all over the world. Everyone knows what they are. Many people own them.
It's like getting like upset about like, why does my kid know that a cow goes moo, but they don't know the sound that the other animals make? Why is it always cows? Why do they have to know that they go moo? It's such a weird thing to be upset about.
Yeah. And not only that, like saying a chicken is related to a T-Rex, we also say that because it's unintuitive and it gets people's attention, because it combines something you're familiar with, a chicken, something else you're familiar with, a T-Rex, and proposes something that's not immediately intuitive, that they're related. It catches people's attention and makes them ask questions. That's why we say it. Like, let's say you take a family that doesn't know this fact, like a family with kids that don't know this fact, to Legoland. They see this, they're like, oh, that's weird. What's that? Like, they'll look it up and they'll learn about like science because of that. It's not insidious. This is it's decent science communication, believe it or not, because it actually gets people's attention.
This is about worldview. And this is about making disciples of your worldview, converting them to that worldview. And chicken is very easy to remember. So every time they see chicken, which they see chicken all the time, they have chicken strips, chicken nuggets, chicken sandwiches. They have chicken all the time. And always like, oh, yeah, I'm eating a T-Rex. I'm eating a dinosaur, chicken. It's always chicken. So then I ask young people, okay, we're talking about evolution. Day 3 of creation, on the 3rd day ever of history, God brings out the dry land out of the water, and out of the dry land, he has vegetation grow. And on some of the vegetation was fruit, and in the fruit was seed, each according to its kind on that day. So let's talk about what that means. If we were to take corn seed and we were supposed to plant it, and what are we supposed to get after so many months? We're supposed to get corn, right? Can we get varieties of corn, different tasting corn, a little different looking corn? Yeah, but it's all still corn. If I plant that corn and I wait millions of years, eventually the corn will turn into bananas. It's the same kind of fruit, right? It's long and yellow, just like the corn, the banana.
And we run face first into the straw man, of course. So, yes, after millions of years, your corn will still be corn because it will always be what its ancestors were. It will be a completely different variety of corn. And by that time, there will probably be millions of varieties of corn, many of which look completely different to one another, but they're still corn. Just like how corn itself is still a grass, which is still a plant, which is still a eukaryote, which is still a living thing. That's how birds are dinosaurs. And chickens are birds, so chickens are dinosaurs. They're just nested categories. And yeah, as people are saying in the chat, just stop with the worldview thing. We're just talking about what reality is. I'm sorry.
Right? And they're all like, no, that's really, if we wait long enough, it'll happen, right? No. Okay. How about apple seed? We plant some apple seed. We're supposed to grow apples. Yeah, we all remember Johnny Appleseed. Okay. Can we get different colors of apples? Yes. Different tastes, flavors? Absolutely. But they're all still apples. Evolution says we plant apple seed and we wait millions and millions and millions of years. Eventually, we might get pineapples. Why not? It's got
Again, it's just the normal creationist straw man dumbassery. I honestly don't think it really needs addressed. But I will say, show them what corn looked like a million years ago. Heck, just show them teosinte. Teosinte is the ancestor of corn. And it looks quite a bit different.
And do you know when corn was domesticated? Was that within like the first century or first millennium BC or first millennium AD, somewhere in there, or before that?
I actually don't know.
I think it was domesticated somewhere in like Mexico or Central America.
I believe so. I don't know when it was domesticated, though. Let's see. Look. Let's see. Looks like it was at least a few thousand years ago. Looks like possibly almost like 8,700 years ago. Looks like. So pretty old.
Yeah, wow. And that's what it looked like originally. Pretty dang different.
Yeah, that's teosinte, or at least modern teosinte. I don't know how similar it looks to its ancestors. I am not a plant person. Also, I saw something that made me want to mention a fun fact. So Sydney Raptor said, corn has been artificially selected by man from maize plants, same as modern bananas. So do you know why banana flavored things don't taste like bananas?
Is it something to do with like the volatility of the like chemicals involved in bananas?
It's because banana flavoring mimics a type of banana that's now very, very rare.
Oh wow. Yeah, because I mean all of the bananas are pretty much Cavendish bananas, right?
I think so. But like banana flavoring mimics a type of banana that I think it experienced like a really devastating disease in the 20th century. So almost all of it was wiped out, which led to the other types of bananas becoming much more common. And, well, those are the kinds we have today. I don't think the other variety is extinct, but I do know it is rare compared to a modern one. or our more common one. Petite Flower says Hank Green made a video about that, and he got one of the other kind of bananas to try. I might look that up later.
Same name, right? That is pretty much the evolution says all plant life came from green algae. Green algae eventually turned into ferns, oak trees, petunias, corn, strawberries, everything. They're like, no, that's it. Okay, here's what evolution said. Cold-blooded, scaly-covered dinosaur, reptile, after millions and millions and millions of years, finally laid an egg that hatched out a warm-blooded, feather-covered chicken. And they're all like, well, no, that's ridiculous. A simple understanding from a child. They understand this.
Again, that's just grossly oversimplifying things and getting things wrong. I cannot speak as to the green algae thing. I do not know plants. But dinosaurs were ancestrally warm-blooded. They were probably ancestrally feathery. Birds just retain those traits as living dinosaurs. They're not unique in that aspect. In none of those aspects are they unique. But that said, we have been going for about, a bit over 2 hours, so I think I might call things to a close. I will say thank you to everyone in the chat for sticking with us. It has been a fun stream. Grayson, thank you for joining me in this last little segment.
Yeah, it was fun. Thanks for having me.
Yeah. Do you have anything upcoming on your channel or any plans at all?
No plans at the moment, unfortunately. Sorry, everybody.
It's all right. It's all right. People in the chat were asking, so I figured I would ask you. I'm working on a few things myself, and I'm also getting ready to go back to college this fall, so that's going to be fun.
Yeah, wow, congrats.
Yeah, thank you. I will say, everyone, hope you have a good night, and we will see you next week, where we're going to continue this, and we might finish this presentation. We'll see. We'll see. And adieu.
Peace.